Thanks a lot, everybody, for inviting me along this evening. Let me just share my screen so it's not just my voice coming out of the speakers at you. And apologies if you've joined and you're expecting to see a human presenting. My camera has decided not to work with Windows 11, which I am running here. So fingers crossed nothing crashes mid-presentation. I've already had Windows Explorer decide to restart on me once. Okay, so let's... If you do have any questions while I am presenting, feel free to whack them in the chat and I'll get to them at the end. Probably the easiest way to do it tonight, just so that we can kind of keep to time. And if I don't get to your question this evening, I will put my email address or my Twitter handle up at the end. Now, I would like that to go back to normal size so I can see everybody. Thank you very much. So I don't have slideware. I feel kind of underprepared when I see the way David does his presenting. So when I think about this topic, I actually want to spend a bit of time jumping through a blog series that I wrote earlier in the year that covers the reasons behind why you would want to containerize a Windows .NET framework app, how you go about doing that, how you then automate the build and deployment of that, and then how you automate the build and deployment of that onto Kubernetes, because we can't have a tech talk these days talking about containers without talking about Kubernetes. But I did want to, I guess, start right at the very beginning and really address the elephant in the room. So maybe a bit of interaction. So who's using containers in their solution? If you're doing that, can you just in the chat window just put in a thumbs up emoji in the chat window? So let me type something. You can just like it if that's what you want. So I put do you use containers in the chat window? So just hover over that, and if you are, just give me a thumbs up just so I can see how many people are out of everyone we've got in the room. So I've cheated because I put one for myself. And I put one other, are you a Kubernetes expert? And I put that in double quotes because I think anyone that really claims to be that is probably not spent a lot of time with Kubernetes, because I think the people who know Kubernetes know how little they really know about it. Oh, someone's sad about not being a Kubernetes expert. Oh, it's David. Okay, well, I'll burst your bubble, David. It's okay that you're not a Kubernetes expert, because most people aren't Kubernetes experts either. All right. So I'm going to start by talking about why do we want to containerize our apps? And I would start by saying, if you're doing file new project today and you're using .NET, you're unlikely to be using .NET Framework. If you are, you might have a valid reason to do that. I would say that the hosting structure for your application wouldn't be a Windows container. And the reason I say that is because when I look at Windows containers and I look at running applications at scale, we've already been through, I guess, one generation of application rehosting through the move from physical hardware to virtualization, and then potentially into virtualization in the cloud environment like Azure. And then when I look at containers, and you may look at containers, you go, well, why would I want to do that if it doesn't have any value for me? And I think that is the starting point. And for me, when I look at Kubernetes and I look at reasons why I would host using Kubernetes and using .NET Framework apps on Windows Server on Kubernetes in particular, really the only reason I would see that you would do this is that you've already, as an organization or as a team, committed to running your application stacks on a consistent platform which consists of Kubernetes as the underlying hosting environment. So that's going to be your container orchestrator. And you've decided that containers are going to be the default method for you to build and deploy your application components as well. If you're not starting with that view of the world, I think you are setting yourself up for a whole world of pain if you go down this route. So I do want to start by saying, because I'm talking about this evening, doesn't mean that it's now the way to do everything. And as hopefully you'll see, is that it's an opt-in. You can start with fairly minor changes and progress down the rabbit warren, for want of a better description, before you really have to start to commit to understand how to do containers in detail, how to do Kubernetes in detail. So I talk a bit about that, about why would I containerize my .NET app? So I've talked a bit about, is it fit for purpose on that scenario I've just talked about? It does give you a consistent deployment and management method across all of your platforms. So if you're in a highly varied environment where .NET and Windows may only be a part of your application in your application or solution environment, potentially it makes sense to standardize on a single deployment approach. I think the third option here, which is pushing ops left in your SDLC, I think that's a valid one as well. And we've spent a long time working on continuous integration and continuous deployment. And if you work in any sort of large scale environment, your access to production environments is pretty much non-existent, maybe apart from the odd troubleshooting session with the help of somebody in your ops or security team. And I think the challenge that many teams still face is building solution components at design time such that they are effectively hands-free to operate when deploying into a production environment. And I think containers very much tick that box because they build an immutable object. Yes, you can still SSH or remote into a container. Yes, you can still change the configuration, but the next time the container is pushed to the container host, all of those manual changes you've made will be lost, and you'll be paged at 3 in the morning and be required to go back and fix that. So it does align very well with the DevOps way of doing things, which is rather than making the quick fix in production, go back to the start of the pipeline, make the change at source, and then push it through the pipeline so that it is captured, it's repeatable, and it goes through the required checks and balances before being deployed. And then the last one for me, this one's probably a little bit less clear. I think the ops and SDLC is probably the clearest one for me. The last one is maybe you have requirements for better app separation. So you could potentially be in a highly regulated industry, or potentially you're running in a business that is doing multi-tenanted applications, but your application design doesn't lend itself to clear separation when running inside of a single app domain or inside of a single instance or virtual machine. So Windows containers and containers, generally speaking, will give you that further degree of comfort that each of the individual workloads in containers have that separation from the other workloads. Additionally, with Windows containers, we also have the idea of an additional VM-based container. For me, when I look at that, I go, well, why would you bother containerizing if you're going to then run it inside a VM? But again, if you have those really high levels of certification required to prove that you're running, in a separated environment, even though you might be running on shared hardware, Windows containers can really tick that box. So that's kind of the 4 sort of high levels for me of why you want to consider this. So hopefully I've not suddenly made everybody decide that Windows containers are perfect for all your .NET apps and that Kubernetes will solve all your problems, because it won't. When we talk about .NET Framework apps, we can talk about a large number of apps, right? That's one of the value propositions of the .NET Framework, is you can build all sorts of application types with it. Unfortunately, not all of them can come to Windows containers, although there are options for it. So for instance, Windows desktop apps, you can't containerize those. They require end user interaction, so that's not really the deployment mechanism for a Windows container. AppV, which is Microsoft's app virtualization technology, is probably a better solution there, but you're not necessarily building your application to support AppV. It's just a way that the Windows Server platform can help support that. If you are running .NET 1.x and 2.x apps, you're out of luck. And I have had somebody tell me before, well, you can still run them in Windows containers, and absolutely you can, but you'll receive no support. And frankly, you probably aren't receiving any support for those apps today. The minimum level you need in order to be able to run a .NET Framework app inside of a Windows container is .NET 3.5. And yes, I know that .NET 3.5 still runs on the same CLR as 2, but the support line that Microsoft has drawn for Windows containers and .NET is 3.5. Now, as I said here, given .NET 3.5 shipped in 2008, you should at least be running that as your minimum. Hopefully you're well beyond that and somewhere in the high 3s or mid 4s, potentially even on 4.8. There isn't really a clear way to take you from those early .NET framework versions right up to the modern framework versions. And if I think about what it takes to bring an existing application to a containerized environment, a large proportion of the work that you will do to achieve that containerization will be dealing with the legacy of what you've got in your code base today. And that's not just a simple matter of, switching the target and then recompiling your app and then fixing all of the things that break. There'll be other things that you'll need to fix along the way. And you've already got a large enough, didn't understand the comment about desktop app. So desktop apps, probably the easiest way is to talk about the apps that are supported in a containerized environment. So really it's for supporting server-based APIs and websites. That's really the target application type that you will put into a container running inside of a Docker container or a Kubernetes environment. If you've got a Windows desktop application that you build and publish to users in your organization, you wouldn't use a Docker container as a target for those application types. So hopefully, Ian, that answers the question. If not, I'm happy to loop back around at the end. Apps that don't have a Windows GUI, yeah. So you could potentially, if you've got a desktop application that talks to an ASP.NET Web API running on a server somewhere, that ASP.NET Web API could absolutely be containerized if it meets the criteria for the framework versions. But the desktop application itself wouldn't necessarily, well, it can't be containerized. The other blocker that's probably going to stop you from moving your web or API applications to a container is solutions that require third-party libraries to be installed, where those third-party libraries require some form of manual intervention when they're installed. So the way you build Docker containers is using a Docker file. Think of it like a really highly customized continuous integration step where your Docker file contains a series of build steps, and when you build the resulting container image, it uses those build steps to determine what the target operating system environment looks like. So typically speaking, in a traditional world, you may have a virtual machine image that has all of your prerequisites pre-installed, things registered into the GAC or into the registry inside of Windows. You can achieve some of that in a containerized environment for Windows containers, but ultimately some of that's going to depend on whether the dependencies you have in your code base can be automated at installation time. So I've got a simple example here in this blog post that shows how you install Iis Node, which is Node.js support for IIS, on a Windows container in the Docker file. So you've got the run command, which is telling the Docker builder what to do. And then we're running effectively a chunk of PowerShell to download the MSI, and then we actually install it using a start process call and pass in a series of arguments. If you've got dependencies that can be installed like that, you should be okay. If your dependencies require you to fill any sort of GUI in when you install them on the server, you're out of luck, or you'll have to find an alternative or go back to the vendor and ask them if they can provide you with a command line style version where you can pass in arguments and install it that way. So that's kind of the high level key things to look out for when you bring your apps to Windows containers. Where it gets a little bit more interesting. So when we talk about base images, and this applies to Linux-based containers as much as it does Windows containers, you can choose from any number of source images. So when we look at a Docker file, we'll see that we have a from definition, and that from definition is our base container image. So you might see from Alpine if you're using Alpine Linux to build a Linux-based container. In a Windows world, you'll see from mcr.microsoft.com. It's basically a full container registry reference to an image of a Windows server container base image that you can use. So what I do here is I talk about a couple of concepts. So if, like me, you've been in the industry for quite a while, you've been used to the regular cadence of Windows Server and then some version, or more recently, some year attached to the end of it. In the new world and the way Microsoft is approaching things, those server versions are called long-term servicing channel releases for Windows, or LTS channels. They still follow a sort of about a 3-year release cadence. And then they have a series of fixes and patches in between those major releases. Now, when you build a container image, you don't patch it once it's built. So it's not like a traditional server where you build the image, you deploy it at runtime, and then it's patched. What you do is you go back and you rebuild the Docker file. You'll pull the latest base image, and that base image will already have all the patches and stuff in that you need. So you do have some changes to the way you operate containers as well. But for the purpose of building containers, you can choose the LTS Windows Server channel. So the most recent one is Windows Server 2019. But there's also a second new concept, which is called the semi-annual channel, or the SAC. And you may have seen this in your environment, where you now have this idea of something weirdly named Windows Server 20H2, okay, or Windows Server 1903. Which, if you're like me, you look at that and you go, it doesn't really tell me anything, but there is meaning in the 20H2 and the 1903 release numbers, and they're released on a much more regular cadence than those LTS versions are. So there's a lot more change in them. They update much more regularly, and the base images that you can pull from in the Microsoft Container Registry are updated, very frequently. So you wouldn't necessarily be continuing to pull Windows Server 20H2 for a long period of time. You might update to pull the latest Windows Server semi-annual channel release version, which might change version over time, but will include fixes and features as you go along. I've posted a link and it'll be available at the end of the session, so you can go and have a look through this if you are interested in that. There's a big description on the Microsoft Docs site that talks about the differences between LTS and SAC. For me, if you are starting to build with container images, you probably want to consider moving to using the SAC channel, because then you're getting all the latest bits from Microsoft. Now, it does put some pressure on you in terms of you might get breaking changes on a more regular basis than if you're sitting with a more traditional LTS release of Windows Server, but it does mean that you're getting fixes and features on a more regular cadence, certainly features, than you will with the LTS Windows Server versions, where you're probably just getting fixes and security patches as you go, and not in new features in those release channels. I'll probably just talk very quickly. Because Microsoft loves to make things complicated, rather than licensing in this case, we actually give you more choice. We give you 4 versions of the base image types that you can choose from. So you can choose Windows Server Core, Windows Nano Server, Windows Server, or Windows IoT Core. Now, for most people, they will probably hover towards the Windows Server or the Windows Server Core, because they will contain most of what they need. The Windows Server base image is the biggest one by far, because it's basically a standard Windows installation with all the bits available to you. You can still take, say, something like Windows Server Core as a base image and then configure additional elements that you require, but it does make your Docker build a little bit more complicated. And some people might just go, I don't want to manage that. I'll live with a larger image and just know that everything is there. The main difference between Server Core and Nano Server is Nano Server will allow you to run .NET Core applications, I think only. It won't allow you to do certain things that require you to access things like GDI inside the Win32 API. All right, so that's kind of the background. I know I cut through a lot fairly quickly, and I haven't done a demo yet, but I do want to move on to the demo. And when I was looking at doing this work, I didn't want to start with a hello world style application, because that's boring. And the point of this talk and the blog series was talking about existing applications, because as an industry, we love to talk about all the new and shiny, and we all love to do the file new project with the latest release of .NET. But there's a very large base of pre-built applications out there that we often overlook. So when I was looking to use something that was realistic, I went hunting for something, and I found the trusty old MVC Music Store sample app. So you're probably all familiar with that. It's been around for ages. In fact, I was surprised that it was still a thing, but it is linked on the official Microsoft Docs site, and it's still referenced from the Microsoft Docs site. So I took that to be a thumbs up for me to go ahead and use it. I'll just ask someone who's on off mute just to mute themselves, please. Thank you. So this is from about 2010, and it was built originally to allow you to understand how the brand new ASP.NET MVC framework was built. And I thought this is perfect because it's got a legacy to it. It's got all the old bits in it. It's probably doing all the sorts of things that an app of that sort of generation would do. Unfortunately, it wasn't as old as I was hoping it would be. The version that's installed or available on GitHub, which was originally taken off of the Coplex site before it shut down, was actually in a pretty good state, which is not surprising, I guess, given it's officially referenced in our docs. We would unlikely reference it if it was in a really poor state. Stranger things have happened, I've guessed. But opening it in Visual Studio wasn't as bad as I expected it to be. I did get a lot of complaining out of Visual Studio when I did it, but you can go ahead to grab that off of GitHub and have a look. So I did originally fork that from Evil Dave MVC Music Store, so I'm not quite sure who Evil Dave is, but he was the person who brought it across from Coplex, and it is the one that's referenced in the doc site. And what did I do with that? Literally, I cloned it. So I've got Visual Studio 2022 here in preview because I like to live dangerously on this machine. When I originally did the blog series, I used a preview of 2019. If you do want to do Docker development, the base version of Visual Studio you'll need will be 2015, and then you need to install all the Docker tools. If you really want a good developer experience, you need probably to be running 2019 or more. 2019 is probably the base one, and I think that's because in those preceding sort of 4 years, the developer experience for building containers using Visual Studio has become pretty seamless, as we'll see in a moment. So when I downloaded it and opened it in Visual Studio, what I got was the usual complaining from Visual Studio about, oh, you'll need to update the configuration. It wouldn't load because, hey, it's an old Visual Studio configuration, so that's not really related to the framework. So it just told me that it would make some changes. It'll still be able to work with older versions, yada, yada, yada. So I said, yeah, go ahead and do that. And everything magically ran. And then I got a bunch of broken packages that, I had to restore. And then the first thing that I did was I actually came in and I changed the .NET Framework target version to 4.72. Now, I could have left it at 3.5, but there was a reason that I wanted to choose 4.72. And it was also a version that I had on my machine at the time. So literally just going in, right-clicking on the project and saying, hey, change the target framework to 4.72. If I show you what that looks like in the app I've got here, this is a different release of the one that you've got there in my, actually 4.72. Okay, I stand corrected. So you can see that there, 4.72. You do need to obviously have that target framework installed on your machine to be able to rebuild to it, but I'm guessing everyone knows that if they're working with .NET on a day-to-day basis, you can't just magically choose a framework that you don't have available on your machine. Now, after I did that, I had to go ahead and do a few things. So one of the things that breaks when you do the update is the MVC version needs to be pulled into line with current requirements. Visual Studio still complains about not being able to do IntelliSense and things like that with that version of the ASP.NET MVC framework, but that's fine. It still works okay. You just don't get all the nice autocomplete capabilities. And I think I had to make a couple of manual changes to some Razor pages to get them to work as expected, but nothing that would flummox somebody who's doing that on a daily basis. I then added this Microsoft configuration builders.environment version 2, which I will talk a bit about in a minute. And then the providers package from the ASP.NET framework, so that all of my identity and auth and user and all that sort of stuff worked as expected. So the code then compiles. I didn't have to go through and make any other changes other than that. So as I said, the application wasn't quite as broken or as ancient as I'd hoped it would be, but that's okay, because it wasn't really about having to fix .NET build problems. It was about getting that code and running it in a container. So I had to then go and modify all of the session state and data store for the database. This sample app uses SQL CE or SQL Express if you have it installed on your machine. So what I had to do was I had to go in and change all of those settings so that I was using a SQL server, and I actually chose to use an Azure SQL database for the purpose of the scenario that I'm running. You can use an Azure SQL. You can use a SQL server database locally on your dev machine or on your local network if you're doing that. But for my purpose, I was using Azure SQL database. I then created some resources in Azure, basically just giving me a serverless Azure SQL database. The great thing about this is that when it's not in use, yep, thanks for the picture. That's what I do look like. Apologies for my camera not working. This gives you a serverless database, which when it's not serving any requests, will spin down the compute and you won't be charged any fees for the compute at that point. You do still pay a little bit for any data that you've got stored, but for the purpose of this demo, you're storing almost nothing. So you're talking about microcents effectively at that point. Because it's a sample app, the MVC Music Store will push data into the database the first time it runs, so you don't need to do anything magical with that. You just need an empty SQL database on the other end. And then I had to go through and make some changes to things like my session provider. Again, a demo, so all I did was I just pushed all of my session state, all of my user data and all of that sort of stuff into the same database. Definitely don't do that in your environment, but for the purpose of this demo, it was the quickest and easiest way to get it up off the ground. And then when I ran the application, huzzah, I got the MVC demo app up and running. So let me go ahead and do that. So what I'm going to do is, you'll see at the moment up here, hopefully this will zoom in. At the moment, I've got Docker selected. What I'm actually going to do is I'm going to change that. I'm going to change that to Iis Express. So at this point, all it's going to do is it's going to spin up and it's going to run locally on my machine. So this would be like I have no Docker tooling installed at all. So fingers crossed my machine doesn't crash and this works as expected. Okay, so you'll see down here in the output window, I've got a warning: could not copy such and such DLL to such and such DLL. That's because I've already run this afternoon just to make sure everything was warm and fuzzy and happy to a container, and that causes that issue on my machine. So what I'm going to do is I'm just going to do a clean on this. So clean will actually do a Docker RM, which will remove my containerized version of the app. And after that's done, I should now be able to just run that and not have that error anymore. He says, crossing his fingers. Okay, cool, that looks good. Let's see which screen my browser pops up on. Okay, come on, you can do it. Don't make a liar of me. And I'm sorry if this is your day-to-day, if you have this experience day-to-day and it feels a bit like Groundhog Day coming to a meetup where someone shows you how to debug a web app. Okay, you can do it. Come on, don't prove a liar of me. Boom, boom, boom. Okay, so it's not paused anywhere, so it's still going. It's just taking a little while. My IP address hasn't changed. Oh, there we are. No, that's my blog. Let's not cheat. All right, we'll come back to that. We'll leave that running in the background because I'm sure it'll load eventually. It might just be that it's spinning up the Azure SQL database on the back end because it's gone to sleep. So that can take a little while to spin back up. This version of the app, the admin section, doesn't work without you making some manual changes to the database, but that's secondary. That's not a result of moving the app. That's just because of the way the admin tooling for this release of ASP.NET Framework doesn't work anymore. So you basically need to go into the back end and manually make some changes to the database. And once you've done that, you can log into the back end and add new databases. All right, so now we've got a working app, which is pretty cool. And the first thing we need to do is we need to add Docker support. And this is the same in 2019 and 2022. Basically, you right-click on the project or projects in your solution that you're interested in containerizing. You choose Add. You do Docker support. Now, in my environment, I can't do that because I've already added Docker support. And what it does is it adds a couple of files. It adds a Docker file and a Docker ignore file, which just tells Docker to ignore a bunch of stuff when it's doing copy activities. Let's just come and say, oh, look, it loaded, yay, okay. And then we can just click around in that. So it's just SQL, Azure SQL database taking a while to warm itself up. All right, cool. All right, so that's our working app. That's cool at that point. And that's just debugging using Iis locally. So we'll close that. That's nothing exciting. So if we add the Docker file, and then we try and debug that. Now, this is where it gets a bit interesting. So if you've been using Windows subsystem for Linux as the backend to your Docker Docker desktop setup, at the moment, what will happen is Visual Studio will detect the fact that you're using WSL for your Docker backend, and it will say, oh, this is a Windows container. We can't run that on a Linux host. And it will reconfigure the Docker desktop for you and set up Windows container support. Now, I was told recently that there's a new capability coming where the Docker desktop can support both Linux and Windows containers at once. So hopefully this step will go away at some point in the future. And then you'll see in this screenshot, the next thing immediately under that red box is pulling Docker images, and then it says Docker pull mcr.microsoft.com/.NET framework ASP.NET 4.8 Windows Server Core LTS, which is what we talked about before, 2019. So we've got Windows Server Core 2019, and this particular base image is a custom one that Microsoft provides. So we have a few that we pre-build that we make available, and this one is a pre-built Windows Server Core version with ASP.NET installed and the .NET Framework 4.8. So it saves you having to custom build that yourself. You can just opt out of having to custom build and go down the route of using this as your base image. Now, you may still want to customize and go down the custom route. You can certainly do that, but I suspect, again, for many people, that this will be the standard way to get their container base image down. Now, this is where it gets fun. If you've not done this before, and this is probably where your internet connection and your developer machine probably need to be not slouchy, shall we say, because what will happen is you'll actually pull down that base image, which in the case of some of the Windows Server images can be in the gigabytes, and download those to your local Docker Docker host, and then have that as the base image locally. So every time you build, you're not pulling the full image down across the internet, you're using the one stored locally. So that can take a while depending on how fast your internet is, and you can run into issues if you don't have enough disk space. So you can just see in this screenshot here that this first chunk of the container image was 1.718 gigabytes, and there was still a whole bunch of other chunks to run. But that only happens once, the first time that you run the app. Now, I've already done that, so the demo later won't take too long. The next thing I want to talk about is making an idempotent container image. And what I want to talk about here is, in a traditional .NET application, and particularly an ASP.NET application, when we deploy it, we can use web deploy to do a deployment time configuration file switch. So a fairly standard way of doing things is to have multiple .config files, either per environment, or using placeholder replacements and XSLT files to do those replacements on deployment, so that when the application is written to disk, the config file contains the values that it needs for the application to run at runtime. You can obviously replace that with custom mechanisms to pull configuration from, say, a central repository or a database potentially, but you still need a database configuration string to do that. So doing that in a container isn't really the right way to go about it. There is actually some workarounds that will allow you to continue to use runtime configuration file transformations to achieve configuration in a container environment, but it's not really a consistent way with the way that you do things in a Linux container environment, which is typically the environment variables held in memory on your machine are what determines the values that are passed into the running container. And you can't do that by default with .NET. It's not a standard part of the .NET framework. And Microsoft has addressed this, but it's only addressed it for .NET Framework 4.7 or above. And that was the configuration.environments NuGet package that I added. If you do have a framework version earlier than that, I guess you could backport it yourself, but Microsoft made the commitment to support 4.7 or above. And if you install that NuGet package, what it allows you to do is it allows you to actually switch out local config file entries and read them from environment variables instead. So you can see here, this is how we connect to our database by default. We have a nice connection string. It's inside the web.config. But actually what we want to do is we would rather not have to provide that connection string. So hopefully you can see that. Let me just zoom in on that. So you can see that there no longer has a connection string. It just says ignored. And we have this first element, which is connection strings. And then we have config builders equals environment. So the config builders NuGet package supports lots of different styles of passing in configuration. If you're trying to align with the way containers generally are built and deployed, using environment variables is consistent with that. So if we run our Docker app at this point, we get a yellow screen of death, which makes absolutely no sense, right? Because I've changed this. Well, actually, it makes sense because I've missed a step. But if you would expect that would be the case, if I had that, it wouldn't be able to connect, and I'd get, rather than a yellow screen of death of this type, I'd actually get a message saying couldn't find the SQL database you're trying to connect to. Let me just hop back over here, and I'm going to hop back into this. So when you install the config builders NuGet package, you get a new config section. You get a new entry in the config section for config builders. And what it does is you're going to say, okay, my builder here in this particular section is I'm only interested in using the environment config builder. And I have a reference to the necessary assembly where that code lives. And then what I can do is I can go through, and it doesn't apply to every single section in your web.config. It's only certain sections, but certain sections can support that config builder type. So if we come down to the bottom, you can see here, this is what I had previously in that snippet in my blog post. So we have the environment here. Now on Windows, the way we would get to that obviously is, let's go here and environment variables. So I'm just opening this on another screen. So this is my environment variables, and I'm going to click on environment variables here. And you can see here in this, here I've got music store entities, and then I've got a connection string to my Azure SQL database in this instance. Now, when I ran the application previously, when I debugged it locally in Iis, that's what I was actually doing. I was reading the configuration from this particular environment variable. Okay, so that's how that worked, even though my config file just has ignored in there. Now, in the case that I've got here in my blog, and I can't repo this because I've obviously already fixed this. If I ran the Dockerized version of my app, even though I've got the environment variable set and I get a yellow screen of death, why do you think that's happening? Does someone want to take a guess and maybe whack it in the chat window, or unmute themselves and say why my app, which runs when I debug it locally, would then give me a yellow screen of death when I debug it by a Docker container? feel like I should have a gavel that you can't see. All right, 3, 2, 1. Okay, so the reason that it doesn't work is that the environment variable that we saw is set on my host, on my Windows machine. It isn't cascaded and passed to the Docker host, which is actually running the container. So as far as the container is concerned, there is no environment variable called MVC music entities or music store entities. It doesn't exist, but we can fix that. So let's take a look at how we can fix that. And we need to be able to fix this so that we can actually debug our containers inside of Visual Studio. Otherwise, we're kind of dead in the water with this new way of doing containerized applications and using the environment variable here. So I'm going to do two things. I'm going to close the config file, and I'm going to come over here to the music store. I'm actually going to unload this. Where are we? Unload project. And then it now gives me the view. And let's just zoom in here a bit. Now, there's no simple and easy way at the moment to do this via the UI. It's not exposed via the UI, even in 2022. So if you are using Visual Studio to do this, you will need to make this change manually. And if I come down here, so I'm in my debug configuration, so my property group here, I need to add a new entry into this file. And it's called Docker file run environment files. And it's basically files that I want passed into the container host when it runs, when I do the Docker debug out of Visual Studio. So that file, which may or may not exist, we'll talk a bit about that in a second, is going to be passed to the Docker host as an argument when it runs. So I don't need to do that manually. I don't need to futz with properties and having custom configurations to debug. I can just pass that in when Docker runs. Okay, so let's close that and reload the project. And let's talk about how we actually reload project. Let's talk about how we create that file. And the way we create that file is we actually do use a build task here. So if we go to a build event and we look in here at pre-build events, what I'm doing is I'm echoing music store entities, which is my environment variable, and I'm piping it into the file, which is in the root of the project. So I pipe music store entities as a string. Music store entities equals the connection string value contained in the environment variable, and I pipe that into the debug underscore config.env file on disk. And then when Docker runs to debug, it will actually pass in that as a parameter. And that means that whatever changes I make in my configuration on my Windows machine will be reflected in the container and made available to the runtime. So now what I'm going to do is I'm going to change my runtime host here. I'm going to change it to Docker. So you'll see I'm going to change that to Docker. And then I'm going to hit run. So down the bottom here, what you'll see is container warm up in progress, and then it will basically work as it did previously with running inside of Iis. It's going to take a little while longer to do this this time because I did the RM on the Docker image before when I was having the DLL copy issue. And if anyone's worried about having to have a brand new spanking computer to do this stuff, this is running on a albeit it was a high spec machine when it was bought. It's a 4 or 5 year old Carbon X1. So you don't have to necessarily have this beast of a machine to be able to do this. It will work quite sufficiently even on existing machines that you have. All right, we'll let that run in the background. We'll come back to it in a minute. It'll start up when it's happy with that. So at this point, what we've done is we've taken an existing application, we've added in the ability to read configuration from environment variables. And at that point, we've actually got an application that runs in a Docker container. That's awesome. So we could actually take that and run it. Yeah, X1 Carbons are awesome. They are. That's why I bought it. I haven't bought one since because I had to empty my bank to pay for it. But hey, life struggles and all of that. So that's kind of, at this point, we've got a containerized web application. Whoop-de-doo. Okay, great. Really what we want to do, and if it's an enterprise style application, you're probably going to want to run more than one of these, more than one instance of this web application. And as soon as you start to run more than one Docker container, you're immediately into a problem, because you then need some way to manage that. And yes, you can do it using scripts and all sorts of funky stuff, but in a large scale environment, that's not really going to be manageable over the longer term, which is where Kubernetes comes in. So it's kind of become the de facto orchestrator and platform of choice for hosting Docker containers at scale. It's not the only thing that's out there, but it's kind of the one that's gotten the most attention and seems to be where the industry is headed. So it's the one that we'll talk about tonight. Okay, what did it do there? Okay, so that's my error. Let me just do a clean on that. Okay, so it's done an RM on that. Just give it one more go. It'll run in the background. Okay, that looks a little bit better. So it's actually running the Docker file, and actually I should show you the Docker file as well. So it's doing Docker run, and then it's passing a command line. And what it's actually doing is it's doing a Docker run, and it's attaching the remote debugger inside of Visual Studio so that I can actually debug against the application that's running. So let's zoom out on that. Hopefully that will show up in a second. And what I did actually want to do is let's just have a look at the Docker file really quickly. This is a fairly vanilla Docker file. It's what gets added when you do right-click, add Docker support. So our first line here is pulling our base image, and it's pulling it from the Microsoft Container Registry, or MCR. And there are a bunch of container images that are available there. It doesn't cost you anything to pull the image. Microsoft provides the MCR for free. Obviously, you need to make sure that you're covered from a licensing perspective for the Windows Server instances that you're using. But in terms of being able to pull the image, we don't require you to log in and do a licensing check before you do that. So even developers could quickly get up and running. We've got a workdir, which is inet pub www root. If you've used the Iis for any period of time, that will look very familiar. Okay, cool. So that's going to debug. Just come back here. And then what we do is once we've finished building, because this runs after you do the Visual Studio build, we actually copy the output from the folder obj docker publish, and we copy that across into our new container image, which is based on this MCR Microsoft.com.NET framework ASP.NET 4.8, which obviously has Iis installed. And when we copy that source across, we're copying it across into the right place inside the container image that we're using as our base image, so that when it boots up, we should hopefully get that. And we can see that that's running inside a container and not on my host, because it's got this funky 172.24.158.201 Docker address, and it's literally the same app. Okay, and we've passed in the container configuration using those environment variable types. So that's cool. All right, going well so far. 2 for 2. Let's talk a little bit about containers and Kubernetes and DevOps. And I've said all of the buzzwords in that sentence, so I hope everyone's happy with tonight's presentation after that, and we'll give a thumbs up at the end. I'm not going to go into the intricacies of setting up Kubernetes, but the thing that we do need to do when we set up a Kubernetes cluster, and I've used, unsurprisingly, I used Azure Kubernetes Service because I don't want to have to manage all the infrastructure. I could use something like Minikube locally on my dev machine if I wanted to, but for the purpose of this demo, I'm using AKS. And what I've done with AKS is I had to make one configuration change. So out of the box, when you spin up Kubernetes, the management plane in Kubernetes is all Linux based. It'll never, and from my understanding is it'll never be Windows based, because from an administrative perspective and a developer perspective, you're not touching the underlying infrastructure that's hosting the backplane for Kubernetes. You're only worried about your node, your pods that will be deployed into node pools, and that's where Windows containers come into play. So if I come and click on node pools over here in the settings panel for AKS, I can see that I've got 2 node pools for this particular Kubernetes cluster. So I've got the default out of the box agent pool, which is from Kubernetes default setup, which is running Linux, and I've only got one of those running. And then I've got a Windows operating system agent node pool, which has got 2 instances running, and they're both running Kubernetes 1.8.19, and they're running on particular types of VMs inside of Azure. So if you want to run Windows containers, you do need to have Windows container node pools inside of Kubernetes. You can't push them into Kubernetes any other way. So I'm just going to take a quick 2-minute break, a bit of a bio break, and I will be back momentarily. Talk amongst yourselves or pop any questions you've got into the chat box, and I'll get to them when I'm back.
Okay, I'm just curious, of the audience, who has done any work with Windows containers before?
I'm going to say I have not done any at all.
Yep. Yeah, certainly there's definitely more of an overhead, just the weight of the Windows containers compared to Linux ones. But I guess as Simon said in his overview of the talk, I mean, sometimes you've got a legacy application that isn't easily moved to .NET Core. Yeah, I think the other thing I was going to mention is comment around if you are dealing with Windows containers and you're trying to run any of this stuff. Well, I guess Simon's talking about AKS, but personally, my experience has been more running containers as part of a build process, trying to line up the versions with whatever container images happen to be on your build agent. If you can get that right, then your builds will happen really quickly because it's just going to use the cache version. But if it's not, then you're paying that download cost and time. So
it's a good point, and it does depend on who you're using or what you're using to build with. I think increasingly you'll find things like GitHub Actions will and Azure DevOps will give you the ability to cache content as part of your build, because ultimately the runners that run those builds are disposable, and you just want your cached items to be close by. And I would say if you are using cloud-hosted runners in Actions or Azure DevOps, builds generally tend to not take too long, even if you're rehydrating items. So when I first ran the build for this particular demo, it would take sort of 11, 12 minutes. And over the last sort of 6 months, that's come down to be like 3 to 4 minutes, even having to rehydrate a Windows Server container image as part of the build. But you're right. Alrighty. So I'm going to skip over setting up Kubernetes because no one came to see that. It is documented if you want to go and have a look. But what I did want to talk about is our old friend, our environment variable, and how that works in Kubernetes land. Because if you think about what we did with our local build host, is we had a build step inside of Visual Studio that generated a simple text file, which was then passed to the Docker agent when it ran during the Docker build, which meant that file showed up on disk, and then the actual Docker host had that available to the running environment. Now, we don't have the ability for the work that we're doing here or the process we're using to use that same process of just copying a file and then passing it to the Docker daemon when it runs. And if we're copying a file into our container image and then deploying that image with the configuration file already in it, does that mean we're rebuilding the container image for every environment we deploy to? If we're doing that, we're not really doing the right thing, because we're building a different image every time we deploy to a different environment, which makes it a nightmare to guarantee that you're deploying exactly the same thing everywhere. We really just want that idempotent container image that goes everywhere for us. Thankfully, Kubernetes gives us a way to pass environment variables into executing Docker containers inside of Kubernetes, and we'll take a quick look at how we do that. The first thing we need to do is we need to take our connection string and we need to encode it as a base 64 string. And then what we'll do with that base 64 string is we'll actually create what's known as a secret inside of Kubernetes. Now, you and I both know that a base 64 string is not that secure, but Kubernetes decided they were going to call it secrets. And I guess at a glance, you can't see what the values are, although you can quite easily decode base 64 strings. So here, because I'm doing it on a Windows box, I'm using a bit of PowerShell. On Linux, I can use a function that will actually allow me to quickly convert strings into base 64 encoded strings. Once I've got that value, I'm going to create a little bit of YAML, because the way you do configuration with Kubernetes is to write YAML files, which, to be honest, is not everyone's favorite file format, and I'm probably one of those people, but that is what the team that developed Kubernetes decided would be the way to go. And you'll have to get used to working with YAML, regardless of whatever tooling you choose to work with Kubernetes for. Although I am starting to see a bit more JSON show up, but frankly, you know, JSON versus YAML, they're both file formats that leave a lot to be desired if you're having to edit complex files in both cases. But what I'm going to do is I define this YAML file, which is a definition for a secret, and I have this secret which is called DB connection, and then it has a secret inside of Kubernetes can have multiple values inside it, but for the purpose of this demo, I have precisely one, which is constring, and then I put my base 64 encoded string at that point, and then I use a command line tool or some other mechanism to deploy that into Kubernetes. So if I have a look at what that looks like once it's deployed into Kubernetes, I'll come into configuration here. And I've got secrets. And there are a lot of other secrets in here that are inserted by Kubernetes and Azure. But we'll see down here, we have DB connection, which is the one that I've created. And there's our connection string. I can click on a little eye and I'll get to see a decoded version of that, but I'm not going to do that. And then I can also see the YAML definition for that. So this will have a bit more information than what I deployed. The blog has basically the minimum version. So there's our secret. So the good thing is that with secrets, what I can do is I can pass those into containers at runtime. So when I define a deployment for a container or a container image, I say I actually want this secret to be made available to the container, and I want it to be used to feed into this environment variable. So let's have a look at how we do that. So that's inserting the secret. Yep. Next thing I want to talk about, and we'll get back to the secret use in a minute, is we looked at this simple Docker file that lives inside of Visual Studio. Now this Docker file is really good for precisely one thing, which is building a debug version of the application inside of Visual Studio and allowing you to debug it locally. You can't use this Docker file to build and deploy, to build a container image that you'll then run somewhere else. And if you try and do that using something like the Docker runner for GitHub Actions or Azure DevOps, you'll just end up in a really weird state, because basically what will happen is it'll build, it'll succeed, and then you'll have no artifact as an output because you're not really doing anything meaningful in this Docker file. So actually what we need to do is we need to create a Docker file that we can use for continuous integration and deployment. So this sample lives in the repository. So if we come over here, so I've got 3 branches in this repository. I've got post containerization and deploy to KAS. So KAS is shorthand for Kubernetes. I'm going to switch to this branch, which is kind of like the Uber finished state. And what we'll find, if we go into the MVC music store completed, we'll find a CI Docker file defined in here. So this file lives sort of at the root of the solution. And then what it's basically doing is it's what's known as a multi-stage build file. And we do 2 things. So we're using a different container image from the one that we saw previously. I'm just going to see if I have that represented over here a little bit clearer. Might be a little bit clearer to see there. So we're using .NET Framework SDK 4.8 as build. So this container image has the full .NET Framework on it, including all of the tools like MS Build that allows you to build your container image. Now, you wouldn't use that as the baseline image for your runtime image. Having things like MS Build and other debugging tools on your production hosts is a really bad idea. So generally speaking, you wouldn't use that as your final state, but it's really handy to use that as our build host because it has all of the tools we need right there for us to be able to build. What I do is I copy my solution, csproj and config files from my solution into my build host. I run a NuGet restore to restore all the NuGet packages that are held inside of the csproj and solution files. Then what I'm doing is I copy the rest of the application code across at that point. I set a working directory of /app MVC music store, and then I run an MS build, passing in a configuration of release because I want the release build to be produced. And then I do, in my second step, there's our ASP.NET 4.8 that we used before. As you'll see, it's called runtime. And my working dir is inet pub www-root. And then I'll copy from my build host into this final container image. So these last three lines here look very similar to the Docker file that's contained here, right? So very, very similar. So it's those additional files, additional steps that we have at the front that actually allows us to build the container image properly. So think of this, these first 13 lines as effectively doing what Visual Studio does for you today. And then this final stage here, when you do, sorry, this is the sort of the traditional F5 style approach, which gives you a binary output. And then this is actually copying it to the host where it'll run finally. So if we didn't do this, we'd basically just be copying source files that weren't compiled into a container and they wouldn't run. All right. So once we built those container images, we need to put them somewhere. So if we use something like GitHub Actions, when we build that container image, that's great. We've got a container image, but if we just go, that's awesome, and do nothing with that container image, the build host or the build agent will go away and our container image will disappear because we haven't published that image anywhere. Again, unsurprisingly, I'm using Azure Container Registry, but you can use any Docker compatible registry that you like to push your container images to. And once you've published your container image, and think of a container registry as like an artifact store for your container images and other files that are associated with container images, which we'll talk a bit more about in a minute. And once we've published them there, we can then deploy them to say something like Azure Container Instances, or in our case, to Azure Kubernetes Service. And Microsoft makes it super simple to do pulls from container registry by associating a container registry with your AKS cluster, which just means that you can say, hey, pull this image from this container registry, and it will all be done transparently behind the scenes without you having to define pull secrets and all sorts of funky stuff, which can be a bit of a nightmare to manage. If you're doing them in the same environment, that makes it much, much easier. All right. Let's talk about how we build our container image that we push into container registry with GitHub Actions. And again, this action is available in the GitHub repository. And basically what we're doing is we're using a Windows host as our build agent. We check out our code, and then we're just running some Docker commands to actually build the Docker file and publish the Docker file up into Azure Container Registry. And then we're logging out a container registry. So basically log into container registry, do a Docker build, which gives us our resulting image. We tag it with a run ID, and then we take that image and we push it up into our container registry. And it's fairly straightforward, he says. If you haven't done it before, it's maybe not that straightforward, but effectively we're doing 4 Docker commands locally to make that happen. Docker has built some additional actions that you can use, but they are a little bit more complicated than doing this approach. And Windows containers have some foibles when it comes to using some of those Docker actions out of the box. What that looks like when you've published. So I'm going to hop across here into my container registry. And under here, over on the left-hand side, I've got repositories, which is where I'll be published to. So if I click on repositories, I should have one repository in here. Two, well, I've got a Helm chart, which we'll come to in a minute. Here's my MVC Music Store web repository. I am tagging my images with latest by default, which means if I pull latest as my tag, I'll always get the most recent version. But then I also have these run IDs, which are unique per run inside of GitHub Actions, and it does give me a particular version that I can then come and pull. So joyously, my filtering extension has filtered out the Docker pull command, but there is a Docker pull command here that would allow you to pull that container image locally if you wanted to. So at this point, I've got image versioned images being deployed into Azure Container Registry, and then I can use those as deployment sources pretty much anywhere I want that I can get a reference to Container Registry from. But in this case, like I said, Container Registry, Kubernetes service will be the place that we go. We're using, just to sort of wrap this up, we're using secrets inside of GitHub to protect our information. So we don't want people to know either where our ACR lives or things even like this, the image name. So in our definition inside of our solution, or sorry, inside of our repository, I can come in and set secrets. You've got those 4 secrets there that are used in the build. And then we've got a final one, which is our Kubernetes config, which is used to actually deploy into Kubernetes, which we'll have a look at in a minute. But because we've got these secrets here, it does mean that we can have those references in our workflows here, and that will be pulled in at runtime. There are environment variables that GitHub provides you as well, but for user-centric information that's custom to our particular application, we're going to pull those in like that. All right, so we've done all of this work. We've built our Docker container. It contains a version of our web application. We've defined a secret inside of Kubernetes. So I guess the next thing we need to do is we need to take that Docker container and actually deploy it into our Kubernetes environment. So the way we do that, I'm just going to scroll down here a bit, is we're actually going to use a thing called Helm. And now Helm is, I guess, optional for the purpose of deploying to Kubernetes, but it does make deploying applications that consist of multiple components into Kubernetes a little bit more straightforward. So think of Helm, what's a good example for Helm? Think of Helm as like the package manager for an application. So it defines the components of an application and how they're deployed into Kubernetes and how they relate to each other. So for the purpose of this solution, it's probably a little bit overkill, but I think it's important to think a bit about how you might do a web application that maybe has a web front end and an API that you want to have a relationship with each other. So you could use a Helm deployment to control the deployment of those components as a single solution. And it's actually not that much more difficult, and it means you're not having to deal with some of the internals of Kubernetes as well. So we'll take a look at the Helm chart in a minute. You'll see here, I've defined the app version as latest, which means that whenever it's deployed, it will always pull the container image tagged latest. You can use proper versioning, so you probably wouldn't have your Helm chart use latest all the time. You would probably have, as part of your build process, the generation of your Helm chart to update it to include the particular ID for your container that it's tagged with. So what I mean by that is this tag here, so this 106987, you could pass that in as part of your build process so that this particular app version latest has the tag on it. And then the good thing is there, every time you look in your Kubernetes dashboard, you'll be able to see exactly what container version you're running, rather than just seeing the fact you're running latest, which is easy, but is not necessarily the best way to do things. The other thing we need to do is we've got to make a few changes. So in another file for Helm, we need to define the repository where our solution lives. So you would obviously update it to be wherever your repository is. We can override the name just so it appears inside of Kubernetes with a little bit more meaningful name than just the container name. So you can put a bit more description in here. Because this is a web application, I'm going to define a load balancer service for it, which gives Kubernetes a way to expose the web application to the outside world. I'm going to define some auto scaling and resource requirements for the individual container hosts. And what that means by doing certainly the resources is I tell Kubernetes how to schedule the container. So it will look for it'll look for nodes with capability to meet those resource requests so that you don't end up with nodes being overloaded with too much work. So that can take a little while to get accurate, but your monitoring and management will hopefully help you understand what the requirements are for that. Auto scaling, it's actually disabled in this particular example, but you could enable it and then say how many replicas you want. So for the purpose of my demo, I have just one replica being deployed, but you can easily scale it out. And then the most important thing here is actually this node selector. And the node selector tells Kubernetes when you're creating an instance of this container image, this is what sort of node I want you to go and select. So that you can do lots of different things here. But for the purpose of this demo, the key thing I want it to do is I want it only to schedule these containers onto hosts that are running Windows, which is where our Windows node pool comes in, because the container hosts in that particular node pool will be running Windows, which means Kubernetes knows I've got this new container, it's running Windows, I need to put it onto a node running Windows. If I don't put that node selector definition in there for Windows, by default, Kubernetes will try and schedule it onto Linux. And then you'll just be scratching your head as to why nothing's running and you're not even seeing a yellow screen of death at that point. All right, so I realize I'm going through a lot. Hopefully you're staying with me at least in some capacity. We'll have a look at a demo in a minute. The one last thing that I want to do is I want to take that secret that we defined previously for our environment variable for our connection string, and I want to deploy that as part of my deployment. Now, this is where Helm comes in handy because I'm doing this all as part of a Helm deployment. If I was doing this with Kubernetes, I would be editing multiple YAML files that may or may not have an obvious relationship, whereas with Helm, all these files will go into a single chart and we'll have a relationship with one another. So I have that nice, easy way of seeing, what settings I've deployed with my application, what type of nodes it's going to go onto. I can do all of that with standard Kubernetes YAML files, but they're just individual files that, then I'm working on convention alone rather than Helm, where I've got it all nice and neatly wrapped up into a single Helm chart. So the key component in this, this definition is this particular component here, which basically says, okay, the environment for this container when you deploy it, or when you can deploy this container, the environment, so env is environment variables. I want an environment variable called music store entities, and I want the value to come from a secret where the secret key is dbcon, and the key inside of that secret that I want to return is called constring. So that will mean that the base64 encoded string is decoded by Kubernetes and written as an environment variable into the running container. So it'll be written for the purpose of Windows. Obviously, it's going to be written as a Windows environment variable at container boot, but it does mean that now I've got one place to keep that information to hand, which is inside of Kubernetes secrets, which is a much better option than most other places. And to be honest, you probably will have some mechanism similar to this if you are running containers at scale. It may not necessarily be the Kubernetes container, secret store, but you're probably going to be doing this sort of mechanism for deploying the configuration for your applications running inside of containers. All right, so that with those changes, and now have a working Helm chart, and that also lives inside of this solution. So if we come back up to this particular branch here, you'll see here we have the charts folder. I'm not going to go into each of the individual files, but all of the information that we need to build and deploy or deploy our application is inside this chart. Helm, the tool, compiles Helm charts, so it turns them into a deployable format for you. And then you saw earlier when we were in the container registry here, so if we come back up to the ACR registry, you'll see here that we have a Helm repository. That's because ACR can also hold Helm charts for you. So you'll see that we have versioned Helm charts as well in here. So a Helm chart and a container version don't have to align necessarily. You might make changes to your Helm chart without updating the container version that's being deployed. You maybe want to add a new secret or change the resource requirements for the container. So you could update the Helm chart at that point and then deploy that. And then what would happen is inside of Kubernetes, Kubernetes would accept the Helm deployment and make the necessary changes for you without having to pull a new container image at that point. So almost there, and then we can breathe a big sigh of relief. Taking our GitHub action. So before we saw sort of up to this point here, we saw build and publish Docker image, which builds our image and pushes it to container registry. Then we want to take the Helm chart that we've just talked about, and we want to build and push that so that it sits inside of the container registry. So at this point, we've got our container image and our Helm chart, which can be used to deploy it. After we've saved it, we're then going to deploy to Kubernetes. So again, we're still using Windows latest, so it's all running on top of Windows latest. These build hosts inside of GitHub are maintained by Microsoft, and we actually publish the tools that are available on these Windows hosts. So in fact, Docker is now a standard part of Windows Server, so you don't even need to install Docker anymore. It's just there, but there are other tools that come out of the box. So Helm is one of the tools that's already installed on these hosts as well, so I don't have to waste any time in my build actually having to customize the build agent. It's already on there for me. So what I do is I take my secret, my kubeconfig secret, and then I'm just going to pipe it out to a local file called kubeconfig. So I read the secret and just pipe it to disk. I add the repo, so that's the one I pushed my Helm chart to before. And then I issue a Helm Upgrade command. So you see, I'm not calling Kubernetes here at all. I'm actually using Helm, and I'm calling Helm Upgrade. So I can do Helm install, Helm Upgrade, Helm uninstall, or Helm delete. The reason I do an upgrade is that if the application already exists and I do a Helm install, it will fail. It'll say, sorry, the app's already there, even if it's a newer release. If I do a Helm upgrade, it will take whatever is there and it will update the configuration based on what it's supplied by Helm. And the only thing I need to supply to Helm is my kubeconfig, which is basically just the secret key to access all of the APIs inside of Kubernetes to do the deployment for me. And once I run this, what I get is I actually will see a set of things happen. So let's come back over here to our GitHub Actions. So this ran 15 days ago, but it's basically what's running at the moment. And I've got a three-stage, this is my 3 stages here. It's just in sequence. I can do branch and all sorts of stuff. But we can see that, you know, we build and publish the Docker image, we build and push the Helm chart, and then we finally do an AKS deployment. And if we expand this, you know, we can see that it issues a Helm upgrade command. So we'll scroll down. You'll see that it was deployed. It'll tell you what it's actually calling down here, and then where it's going when it's deployed. So we can actually come in and look at, you know, each of these commands. And some of the data's gone from here because it's a bit old, so it's been purged. I can see this, and you can't. because I'm logged in and it's my repository. If you go and look at the Actions tab in this repository, you won't see this level of detail. Even if it's a public repository, you can't access this level of detail. GitHub Actions, what software is pre-installed? Yep, that's cool. Thanks for that, David. Yeah, and so basically what would happen at this point, now that I have this action defined, every time I push an update to my application into GitHub, it will trigger a build. Now I could do multi-stage build so that every time I push a change, it's not doing a full deployment to Kubernetes. But for the purpose of this demo, I'm doing end-to-end, but I could easily just have a build that's triggered automatically that does, you know, that sort of build the container image and update the Helm chart. And then I could have a branch at that point that requires intervention from somebody to approve the deployment to Kubernetes at that point, or potentially I could deploy up into another, you know, environment to pre-test the application before approving the deployment into my final production Kubernetes environment. Quick plug, if you do want to see how that sort of stuff works in real life, come along to the new Breakpoint session tomorrow with me and Anthony, where he'll show that process and how you can use that kind of PR-based approach and approvals approach to drive safe deployments with GitHub Actions. I think we're pretty much at the end. So it took 11 minutes. It's a little bit quicker than that these days. Let's have a look, see if it'll prove me wrong. Let's open this. So it says there it ran for 3 minutes and 46 seconds. So it's come down a fair bit in the time, and it'll vary by time of day as well. So it could be that I ran it at a good time of day. So you can see here it was almost 13 minutes, this one. All right, and then we've got one last thing to do. So this is the real test, and I actually know this works. So I'm going to take the sail out of the wind out of the sail a little bit. Is if I come into my Kubernetes cluster and I open services and ingresses, I'll see down here, because I didn't use an ingress, I just exposed it via a load balancer. I've got an IP address here. If I click on that, there's our ASP.NET MVC .NET 4.8 or 4.72 application in a Windows container inside of a Kubernetes cluster, talking to a SQL database, in our case, Azure SQL database. And I haven't had to make any specific code changes to enable that. And in fact, I could go back and edit my code and just run it in Iis on-prem if I really wanted to, without having to make any real changes to it. And that's pretty much it, I think. Sweet taste of success indeed. I will quickly put this up and then I'll open the floor for questions. If you want more info on this talk, that really cryptic akka.ms link at the top will take you to a page where you can get access to my blog. Thank you very much for the applause. New Breakpoint tomorrow. If you do want to get to that, I will put the links, both of them, in the chat so you can quickly copy them if you want. So that's the short link, and new Breakpoint tomorrow. That's it. So any questions from anybody? I know there was a lot. That kind of went from 0 to about 6 million in an hour. So I appreciate if it's not something you do a lot, there may have been a lot of info in there. But shoot, any questions you've got, happy to answer them if I can.
Feel free to
just wanted to say awesome. Thank you very much.
Thank you.
I was going to say, feel free to unmute if you want to ask the question in person or in the chat, if you prefer that.
I don't bite, I promise.
I'll throw one out. We find that the overhead of Kubernetes and trying to run them is greater than a bunch of other techniques like running the hosting in Azure PaaS and the like.
Yep.
At what point do you think it's worth looking at Kubernetes over those strategies?
It's a good question. So I think it really comes down to one of scale and platform independence. I'm just bringing something up here, and I'll put it on my screen in a second. It's a good question. So for those of you who aren't, where are we? Here we are. Good. Just opening this up. Bear with me 2 seconds. So I don't know if you've seen this Azure compute decision tree, and it kind of takes you through VMs, batch, app service, functions, container instances, service fabric, and AKS. Look, I think if running containers on Azure App Service, and for those of you who aren't familiar with Azure App Service, it's a web and API hosting service in Azure where you don't manage the infrastructure, and I wouldn't say it predates Kubernetes, but it was doing some of the stuff Kubernetes now does before Kubernetes was widely adopted. I think where people pick app service over Kubernetes is very much dependent on if they've chosen Kubernetes as their orchestrator / hosting platform of choice, oftentimes as an attempt to be platform agnostic. I actually think Azure App Service and containerized apps is a really good gateway to get into this space without having to deal with the complexity of Kubernetes. But I think, as I said right at the top, I think if your starting point is we have to build our app to run it on Kubernetes, then I think your starting point is the wrong starting point. I think really for me, there has to be some mechanism in the way you run your business or the way you run your software that means that Kubernetes is the right solution for it. And that's a very hand-wavy, loose way of talking about things, but I think there will be certain criteria that you would have to meet in order to run, on top of Kubernetes. And like I said at the very top, if you're doing file new project, you shouldn't be doing .NET Framework on Windows containers on Kubernetes. I think you set yourself up for a world of complexity and hurt. But if you do have apps and Kubernetes is a broader decision that your team or your business has made, then it makes sense to go down that route. Don't know if that answers your question, Luca.
Yeah, it does. It's sort of similar to my observations in what we do, and also in a lot of our clients. Wherever we've got clients that use Kubernetes, they seem to end up having quite large teams of essentially what become infrastructure people again. Whereas a lot of the PaaS, app service plans and app services tend to do away with some of that. But I do take your point that it really comes down to a lot of the agnostic properties of Kubernetes.
Yeah. Look, I'm always, this is me talking as an individual and not as a Microsoft employee. I'm always amazed when I come across these tiny startup businesses that are running their business on Kubernetes, and it's just amazing to me, because the amount of whether you're running on something like AKS or EKS or GKE, and apologies if those three terms don't mean a whole lot. Even though those take away a lot of the complexity, really to get the most out of running your app on Kubernetes, you need to have a person in your organization that understands it very well. And to your point, Luca, you're back into the world of specialization and ops doing ops and developers doing development, and that's not really where we're trying to get to as an industry, right? So
yeah, exactly. I think that's a very good point, that we've been working so hard to unify dev and ops, and as awesome as Kubernetes is, and I do think it's awesome, that tends to be the natural conclusion that we observe, that you end up having a bunch of people separated out into specializations again.
Yeah. And typically single person or small team dependency for specialists who understand Kubernetes to the level of detail required to operate it effectively at scale.
Yes, definitely.
But the one comment I would add to that, and apologies for taking time for other questions, but if you look at and I'm sorry, I am plugging Azure here, but it is part of my job. The other thing where I think it let me just see if I can get this up. This one actually is, I'll just see if I can find a proper link to a Microsoft site and not some third-party blog that may or may not have all the information on it. So this is the announcement. So this is where I think Kubernetes starts to make sense to me, which is taking app service, which Luca, you were just talking about, containerizing that as a platform, running that on Kubernetes, and then making that available to run anywhere. Now that to me is where I see Kubernetes fitting in, and then in that case, Kubernetes effectively disappears into the background. But again, you do need the capability to run that. But I do see in highly regulated industries where they're trying to do multi-cloud and they've chosen Kubernetes, this ticks a very big box, which allows you to build on app services, on Azure, using PaaS and not worry about Kubernetes, but also meet the platform agnostic requirements you might have that are serviced through Kubernetes, but do it in a way that means that your developers only need to care about app service and not about Kubernetes. That works for me. It's in preview at the moment, so I guess time will tell if everybody else agrees with me or not.
Awesome, thanks for that. I wasn't aware that was coming. That's cool, thank you.
Yeah, I've got somebody lined up for New Breakpoint, hopefully a little bit later in the year, that's going to do a half hour on this. It got a lot of attention back at Build. I'm yet to have a play with it, but I do think it has a lot of potential. Any other questions? Good question though. Thanks for that. Blown everybody's minds. All right. Well, look, I'll chuck my email address in the chat, and I'll also put it on the screen. Dave, if you want to wrap up in the meantime, I'll just quickly type this up. And then if anyone's got any questions, they can always reach out to me. Happy to take emails or tweets or whatever.
Cool. Well, thank you, Simon. So as sort of Simon wraps up, that was a really in-depth talk there. Sort of interesting to go back and see the old .NET framework stuff that many of us probably have spent a lot of time working on. I guess it makes you appreciate when you get to work on the newer .NET Core bits. But yeah, there's still plenty of old framework stuff around. Thanks everyone for joining us. We'll be back again next month, and we'll have more information about that coming out soon. Hopefully, wherever you are, you're keeping safe, and if you're in lockdown, hopefully that doesn't last for too long. Wish you all the best, and we'll catch you all again next month. Thank you, and good night.